Hey everybody, Mr. Alent here. So we're going to go over from Chapter 9, Section 2, how to find the area for regular polygons. Now to do that we have to define some terms, and so you can see our vocab here. So the first term is what is a regular polygon, and the word regular is very specific to meaning something here. And it's where the polygon is both equilateral, or all the sides are equal, and equiangular, all the angles are equal. So basically it's like your perfect, here's like a stop sign kind of looking octagon, right? This perfect octagon where all the sides are the same and all these angles inside of there, those are all the same angles. That's what makes a polygon regular. And so this formula we're going to show you for finding the area of regular polygons does only apply to regular polygons. It doesn't work if the polygon is irregular, okay? The center of a regular polygon, it's exactly what you think. It's the point right there that is equidistant, same distance, from all the vertices of the regular polygon. So like these two distances, they're the same, which is what's making that the center. All right, and they would be the same if we drew them all in there. Okay, now this is a really important term here, the apothem. The apothem is the distance from the center of a regular polygon to a side of the polygon. So right here, when we talked about the center, we talked about from center to vertice, but now if we're talking about the apothem is going from the center to a side. And if you think about distance from a point to a line, it has to be perpendicular distance. And so this is our apothem right here. I'm going to highlight that. Highlight the apothem. Right, so I did that in my highlighter yellow here. That is our apothem, and we usually just call it little a. Right? So little a, there's our apothem. It's going from the center to a side of the polygon at a right angle. That's the apothem. That's going to be really important, and there's the a right there in our equation. Here's our area formula up here. Right? Area is 1/2 times p times a, and I'll talk about p in a second. But there's that apothem. Okay. And then something else we need to know, the central angle of a regular polygon. It's an angle formed by connecting two vertices to the center. So like this example here, so we have, let me use a different highlighter here. I'm going to use my green. So like that angle right there, that's created by these two guys, which are connecting two vertices to the center, two consecutive ones. That's what creating what's called the central angle of a regular polygon. Okay. What we're going to need from that, there's something really important that comes along with that. So the central angle, and again, it's got to be for a regular polygon. This doesn't apply if it's not a regular polygon. But the central angle you find by doing 360 and dividing by the number of sides. So 360 divided by the number of sides tells you what that central angle is. By the way, so we can find that real quick. We got we've got an octagon here. We've got 8 sides. So the example that we have, 360 divided by 8 is going to give us 45. So this is a 45-degree angle in there. That's what we're saying. Central angle gives us that. Or that's how we get the central angle. The angle right there. Okay? In the equation, back up there again, where we're looking at our equation for the area of these shapes, the P stands for perimeter. Okay, so it's the sum of all the sides, right? The sum of all the sides. All right. One thing we'll need to know too is that, well, we'll see some examples. Let's go on to an example. So there's our formula. It's not that hard of a formula if you think about the things that are in there. Just 1/2 times p times a. P is perimeter, a is apothem. But where this can get tricky is, what are you given? What are the things they give you to start with to help you find those other things? So here we go. turn the page. We got our first example. We'll do just one in this video, then I'll make a new video for examples 2 and 3. And there's really 3 ways we can send this at you. Either you're given, well, let's just do, this is one where you're given the apothem. Right, so it says right up here at the top, when you are given the apothem. Right, the other possibilities, you could be given a side length. So if you look at the picture, right, apothem, we're given the apothem is 4, find the area. Here, we're given a side length, oops, I went off there, sorry. Given a side length, find the area. And then the third type, and again, you'll see the second and third in another video. What if I'm given what's called the radius, where we have that center to a vertice, that's called a radius. I know it's not a circle radius, but it's still the same idea. If we're given that, can we find the area? And we can for all 3. And those are the 3 ones that we can give to you. So let's focus on the apothem first, if the apothem is given. Okay, remember, you always need to think about what's the formula, because that's the key really too, is remembering what are we trying to do here. Sometimes these problems can be so involved that we forget what we're doing. And the key is right here, right? We're trying to plug in into A equals 1/2 P times A, right? We're trying to put in P and we're trying to put in A. That's what we're doing. That's the goal. But we got to get each of those. Notice, I don't know P. I don't know the side lengths, so I can't find P right now. Now, A is easy because it was given. A is the apothem, right? Don't forget that. So this little 4 feet up here, that is our apothem. So we're starting with that. We got to find a way to get the perimeter. All right, and here's what we do. We are going to draw a triangle. All right, so I'm going to draw that little triangle right there. Okay, and then this is that triangle just blown up, so we can work with it a little bit bigger. All right, so we're dealing with that triangle there, so which means that 4 feet, that's right here. That's 4. Okay, now what we're going to do, we're going to find this angle right here. We're going to find that little angle. And how we're going to do that is we're going to find the central angle for this shape, right? So if I find like the central angle, let me draw just maybe another triangle over here, like that. Do what we did to find that central angle. Okay, we do 360 divided by the number of sides. This is 8 sides, which this is the one we just said is 45 degrees. So this central angle is 45 degrees. Now, one thing to be very careful of. The central angle is 45 degrees, but what's this angle? What's this angle we're trying to find right there? And I guess I should have wrote it. We had the space over here for this. And so we did 360 divided by 8 gives us 45 degrees. So there's our central angle. But then the key is what we're going to do. This, when we drew that apothem down here, it essentially, you know, if you think about what's going on here, if you draw the apothem there, for instance, you're going to cut that triangle in half, and you're going to cut that angle in half. An apothem is an angle bisector. So it's bisecting that 45-degree angle. So if I take 45 and cut it in half, divide by 2, I will get my angle. So 22.5 degrees. So we're getting half the central angle. You are going to do that for every problem. All 3 of the types, this is where you start. Find half the central angle, because every one of them is going to be dealing with a triangle. Okay? So that's a really important piece. We're going to have to find that. Now, if I look back over to my picture here, so we just found this is 22.5 degrees. And now it says we're trying to find x. Where x is in the picture, we haven't put it there yet, but we're going to put it right here. Because if you look back over here at this triangle, that's this little piece right here. What we need, again, think back to what we're trying to prove. We're trying to find the perimeter. Well, to know the perimeter, I need to know the side lengths. Right? So x is going to help us get to those side lengths. Now, keep in mind, x is only half of the whole side. So once we find x, we'll have to double it. And then we can find our perimeter. Okay, and look at right here. It says we're going to use trig to find x, right? Look at the picture. Look at the picture. This is exactly last chapter, right? If I'm trying to focus on trig, so ignore all the other stuff right now. This is a trig problem, and I say find x. Well, what do? We label sides. There's O, there's A, there's H. All right, so if I'm thinking about SOHCAHTOA, right? SOHCAHTOA. It looks like we're looking for O, and we know O and A is a tangent. So I'm going to do the tangent of the angle, 22.5, equals the opposite x over the adjacent 4. Now be careful, this capital A is for adjacent when we do trig, not the same as little a for apothem, right? Different things. All right, so we're solving for x, so we're going to do 4 times the tangent of 22.5. And that we just put in the calculator. And that's going to give us a 1.7. We're rounding to the nearest tenth, so call it 1.7. Okay. That's going to be feet. It is a length, right? Because we're dealing with feet, it looks like, from the 4 feet given as the apothem. But again, that's x. X is half of the side. So the whole side is going to be 2 of those x's. So 2 times 1.7 is a 3.4 feet. All right. And now we're ready to get our perimeter. So the perimeter, right, you got to think about what we have here. We have an octagon which has 8 sides, and so if I knew the side length, then we would just do 8 times that side length, right? So 8, I'll just call it S for side length. Perimeter is 8 times the side length. Well, we just found that side length. It's 3.4. 8 times 3.4 is 27.2 feet. And now we are ready to finally solve this, because we do have P now. We just found it. A was given at the beginning. So area is 1/2 times the, and I would usually write it out, but it's right there, times the perimeter, 27.2, times the apothem, 4. And that will give us the area of this octagon, which, when we do the 27.2 times 4, then divide by 2, it's a 54.4 square feet. Again, it is area, so square feet. Whew, and there you go. These are pretty involved problems. There's a lot of steps to them, so make sure you're following these notes very, very closely. Okay, I'll do another video for the other 2 examples.